brand ourselves as the Virgin Galactics! I'm here to present our mission, to propose to you the most effective star out of the 4 systems that can effectively heat up your water in no longer than 30 minutes. Therefore, we need a heating system that best applies all the requirements, such as the traveling distance, the time to heat, and the cost. This is our spaceship. Be able to operate in above densities of 500 watts per meter squared. Secondly, our spaceship can travel at an average of 6.6 times 10 to the 7th meters per second. Third, for every week of time travel, we lose $3.5 million. Our initial cost of spaceship will be $820 million. So here's our proposal. Our heating device is 70% efficient, and for each second spent on the planet heating the water, it'll cost us $180,000. We are given 4 systems. System A has a very bright blue star. System B has a very dim white dwarf star. System C has a yellow main sequence stars, and System D has a red giant star. As mentioned before, our heating device is 70% efficient, and each second spent on the planet heating the water costs us $180,000. Here we have the CEO, Marini Martinez, the woman of the calculations, to briefly explain why you should invest in our systems.
Well, here, seeing System A, we use 3 main calculations. We use Finn's law to take the temperature, which is in kelvins. We use 7 Boltzmann's law, which is luminosity that's measured in watts. And finally, we have the intensity equation that will help us know if our device is effective or not. In this case, System A is not effective because the amount of watts per meter squared is limited to 9,845.14 watts per meter squared. In other words, System A does not qualify for the petition because it's above 500 watts per meter squared. Continuing with System B, again we use the 3 main equations. The intensity is 5.0634 watts per meter squared. And you should consider this system because the intensity is between the range of 100 to 0 watts. Moving on, System C is another option you should consider. Why? Because intensity is 356.52 watts per meter squared, which is also in the range of the 500 watts that you have limited us. And as seen here, we use Finn's law to calculate the temperature, which helped us find out the luminosity, which helped us find the intensity. Lastly, System D is not an option. Why? Because its intensity is 52,930.82 watts per meter squared, which means that it is much higher than 500 watts that it is required to heat the water you need. Which concludes that System D does not qualify for the petition because it is above 500 watts per meter squared. Regarding travel time, System C is Sorry, we had technical difficulties. Well, as I was saying, System B is 750 trillion weeks, while System C is 1,000 trillion weeks.
And of course, how can we forget the calculations? Let me show you. The total cost for System B is $12,764,267,600. And the total cost for System C is $10,642,334,800.
After making hard calculations, we concluded that the winner is System C! Out of all the systems, System C is the one that suits all the requirements. Less cost, less distance, less timing, and greater luminosity, which also means more heat.
Have your tea faster and warmer!
It's the one and only Digo Double G. Snoop Dogg. You know I'm mobbing with the D.R.E.
Yeah. You know the West Coast is back for all you